when I do these, the very first step I do is I figure out the direction that these electric fields are. And then I stop and I double check the direction because that's the most common mistake. Okay. So B is going to create an electric field that's away from it because B is a positive charge. So therefore it's going to be like this. Okay. So EB is going to be away from it because it's a positive charge. Therefore it's up and left. And this angle with the x-axis is 45 degrees. Right, which makes it's going to have a positive x component and a positive y component. That's important. Okay. Now A is a negative charge, so electric fields are toward negative charges. So EA is that direction, right? And that direction there. So that's going to have, EA is going to have a positive x component, but a negative y component. And this angle right here is going to be a tan, or tan minus 1 of, let's see, what is it? 1, 2, 3 halves. And a tan of 3 halves in degrees is 3 divided by 2. 56.31 degrees. Okay, below the x-axis and to the right. Okay, this will become important. Now, the next thing you got to do is you got to figure out the magnitudes. You don't want to mess up any of these steps, right? You mess up this, it's just like a house of cards. Okay, so we just got to do slow, careful work. So EA is, and we're just using KQ over R squared. So EA is going to be 8.99. E9, and the E's here mean times 10 to that, right? Okay, and then A is, what is A? 3.2 microcoulombs, so 3.2 E minus 6. Notice I blithely ignored the minus sign because otherwise you get like negative magnitudes, and I'm just not smart enough to figure out what that is. Okay, so let's see. And A is 2 over 3 down, right? So it's going to be 2 squared plus 3 squared. Now, really, I should be taking the square root of that and then squaring it. But if you do that, the square root and the square go away. So this is what you end up with, right? All right, so let's do that. Alpha F1, 8.99, E9 times 3.2, E minus 6, and then in the denominator, 2 squared plus 3 squared. Okay, I'm using a fraction. If you don't use a fraction, you have to put, these parentheses are obligatory. Obligatory. All right, here we go. What do we have? And that's 2212.92. That's my magnitude. Okay, and that is down and right at this angle here. Okay, and then let's figure out EB. That's going to be 8.99 E9, which is what I tried to write there. And then B is 2.4 microcoulombs. And then let's see, what's our denominator here? B is 2 over 2 down, so 2 squared plus 2 squared. I'm going to put the parentheses there because not everybody's going to use a fraction, right? Okay, so let's see. Okay, 2 squared and 2 squared. Let's go up. And 2.4 microcoulombs. So this guy's 2697. It comes out even. Like, what are the odds? What are the odds? Oops. Newtons per coulomb. Somehow I got to 7 and I wrote the n. So 2697. That's kind of cool. Okay. So now we're all ready. We can go the charge, the name, the magnitude, the direction, the x component, the y component. Oh, look at this. If only there was a way to draw a nice straight line. I do covet that about this version of PowerPoint, is that it lets us do straight lines like that. Look at that. Whoa. Our magnitude, our direction. Okay, let's see. Oh, look at that. I want to put one over here. It'll feel so cozy. Okay, here we go. Wow. Oh man, this will be their sum. Okay, so let's see. Let's go EA and EB. Our magnitude of A is 2212.92. This guy is 2697. Now, by the way, a common mistake here is to switch up these directions. So let's not do that. Okay. So the direction of A is 56. That's A, right? 56.31 degrees, and it's in such a direction as it's got a positive x component, but a negative y. Okay? Positive x and negative y. And then this guy is 45 degrees, and that's a positive x, because it's here, positive y. And I just do that because I'm a spaz. I'll at some point forget and mess up. Okay, so now we're set. Since these angles are with the x-axis, then I can always use cos to find, it'll give me the absolute value of the component, and then I'll just use these pluses and minuses to make them plus or minus. Cos always gives me x, sine always gives me y. So let me give you an example of this. Okay, so 2219 cos 56.31. Let's find that number. There it is. Okay. And this is 1227.5. Okay, that's my x component, right? And then if I want to find the y component, I take exactly the same expression, only I change the cos to a sine. Let's see if I can do that. Oh, bingo, it did it. That is awesome. Hit enter. 1841.26. And this makes sense, by the way. This vector should have more y than x. It should have a negative y component, right? Positive x. So yeah, that's looking good. Now let's try this guy. 2697 times cos of 45. I know I could be clever and do something with like the square root of 2 over 2 or something like that, but I'm way too lazy. Okay, so I'm getting 1907.0. I'm just going 1907.1. Okay, and this vector here is to the right, and it's up. So these are both positive. So now I'm all set. Now I can add these guys up. So the 1227, there it is, plus the 1907 is 3134.57. And then this guy here, the opposite of that guy, so find it, there it is. Plus all of this guy, right, plus 1907. The up arrow is very handy. I'm getting 65.804. All right, now we got to draw a picture of this. Let's draw it. Okay, so it's to the right. Wingy, 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 wingy. It's up just a smidge. Right, that's an exaggeration, I'm sure, and then it's this guy. Okay, so that angle is minuscule. That angle there is a tan of 60, of opposite over adjacent, right? 65.804 divided by 3134.57. All right, here we go. Second tan of that guy divided by this guy. 1.20 degrees. That is 1.20 degrees above the x-axis, just like that, right? Okay, let's find the magnitude. My magnitude is going to be the square root of 3134.57 squared plus 65.804 squared, which is going to be remarkably close to this, the way square roots work, right? Okay, so let's find the 3134 squared. And then in this case, be very careful if you had a negative component. Remember, if you're using the up arrow, it's going to pop it in there with its minus sign on it. Then when you square it, your daft TI calculator is going to tell you, is going to give you a hypotenuse that's shorter than the one of the sides, because it evaluates a negative number squared as a negative number, which is, in my opinion, incorrect, but that's okay. Okay, so the magnitude I'm getting here is 3135 newtons per coulomb, right? It didn't budge the needle very far, right? It's like, well, all that stuff. Don't you feel bad for the 65.804? Okay, so there we are. We got 3135 newtons per coulomb, and it's to the right and up. You need to draw a picture of this. Label the angle, and you're set. Okay, is there anything else to say? I don't think so.